For today's project, we're going to be chemical engineers to design a project called Magic Milk. In our experiment, we're going to create chemical reactions and observe the colorful patterns that they make. Now that we know what we're making, let's make sure that we have all of our materials ready. For this project, we will need 2 cotton swabs, 2 paper plates, 2 9-ounce paper cups, and then outside of this, you will also need some food coloring, about 3 to 4 drops per student. You will also need some measuring cups in order to measure out the next materials. It's recommended to have about 2 sets per 7 students. Then you'll need to measure out a half cup of 2% or whole milk. You want milk that has a high fat content, so that's why it's recommended that you use either 2% or whole milk for this project. You'll also need to measure out 1/4 cup of dish soap. And to make sure that everything stays clean, we will need some paper towels. This experiment can be messy, so make sure that you do have napkins or paper towels ready. And each student or student pair is going to get their own plate with milk and a set of cotton swabs, but the rest of the supplies can be shared within larger groups. Once you have all of your materials ready, we can start our project. While creating your experiment, don't forget that food coloring can stain your hands and your clothes. Make sure that your students are being careful and help them if they start to create a mess. You may also choose to add the food coloring drops for them as well. We will start by grabbing 1 plate and our milk. You want to pour just enough milk to cover the bottom of the plate and then a little bit more. Try to avoid overpouring during this step because our chemical reactions will work better with less milk. You can also pour some milk into paper cups and have your student pour the milk onto their plates from the paper cups. As the instructor, you can help facilitate this step with your students. Next, grab some food coloring of different colors. Add about 5 drops total surrounding the center of the plate to form a circle. Don't pour too much food coloring in one spot, as it might cause the food coloring to drop to the bottom of the plate. So as you can see, my food coloring should stay on top of the plate. You want to avoid having it drop below the milk. And once you are done, if you have more food coloring left, you can add some more drops around the plate. After you're done, you can set your plate aside carefully without mixing the food coloring. And we're going to grab our other plate. And we're just going to put some dish soap onto it. You don't need to fill the plate. You just need to add enough dish soap for your students to use. If your students are in groups, you only need 1 plate or a cup of soap for multiple students. And once again, you can facilitate this pouring step for each group. So I'm going to take my dish soap. And since it's just me, I'm going to pour just a tiny bit for myself to use. Now, the final step for us to prepare for testing is you're going to take one of your cotton swabs, dip about half of it into this dish soap so that it absorbs into the cotton swab, and then we'll set that aside for testing. So now that we've prepped our experiment, after you're done, you can set your plate aside carefully without mixing the food coloring, and we're going to grab our other plate. And we're just going to put some dish soap onto it. You don't need to fill the plate. You just need to add enough dish soap for your students to use. If your students are in groups, you only need 1 plate or a cup of soap for multiple students. And once again, you can facilitate this pouring step for each group. So I'm going to take my dish soap. And since it's just me, I'm going to pour just a tiny bit for myself to use. Now, the final step for us to prepare for testing is you're going to take one of your cotton swabs, Dip about half of it into this dish soap so that it absorbs into the cotton swab. And then we'll set that aside for testing. So now that we've prepped our experiment, we're ready to move on to the testing phase. You can take your cotton swab, you can get a new one, or you can use the one you already had and dip it again into the dish soap and then place it back onto your milk to continue to test, and watch it swirl around. And if you have enough time, you can use a second plate of milk to try again. And you can encourage your students to place the food coloring and the cotton swab in different places. You can also encourage them to add more or less soap, more or less milk, and experiment to see how it changes the end result. If the experiment is not working at all, make sure that your students properly dipped the cotton swab in the soap and ensure that the food coloring did not all sink to the bottom before the students started testing. You can also try moving the cotton swab around in the milk to try to get a part where the food coloring is more condensed, and you will start to see it swirl around. Now that we are done testing, let's talk about how it works. Milk is made up of vitamins, minerals, protein, and fat. Dish soap is designed so that its soap molecules stick to fat molecules. When the dish soap comes into contact with the milk, the molecules start to move around and bind to each other, and as the dish soap molecules look for fat molecules to bind to. As these molecules move around, the milk itself starts to move. This movement is normally very subtle and hard to see. However, since we added the food coloring, we can see the movement caused by the molecules swirling around the plate. If we try milk with a higher fat percentage, the soap molecules will have more fat molecules to bind to, whereas if we use milk with a lower fat percentage, there are less fat molecules and less movement as the soap binds to those molecules. Chemical engineers design soap so that it can attach to dirt and grime, and that's why it's able to clean surfaces so well. It's not something that we think about every day, but chemical engineers work hard to develop safe solutions and chemicals that we use in our daily lives, such as dish soap. Now that you know how our magic milk experiment works, there are some things that you can think of with your students, such as what would happen if we had milk with even more fat? What about if we had less fat? What if there was no fat in our milk, or if we just used water and soap? And why would chemical engineers want their soap to bind to fat molecules?